I want to do a little setup for today's lab. This is my magnifying glass, and here's how I'm supporting it. I'm putting it in a jar full of sand. That allows it to stand upright. Figure out what you want to have your magnifying glass stand upright. Has to be a magnifying glass. Has to be something that makes small text or small things appear bigger, for reasons we'll talk about in class. This is a screen that I'm going to use to shine the image on. You can see there's something being shined on there by this lens here. And what's being shined there, you'll see it when I turn off the lights. Excuse my messy garage, but I have some Christmas lights that are outside, but that they come into the inside to get plugged in, and they're shining on the inside. So that's going to be my light source for this first image that you're going to see when I turn off the light of the garage, as a result of the light passing through this lens and creating an image on the screen right here. I'm going to turn off the light and you'll be able to see that more clearly. Okay, so there's the image on the screen. Now notice what happens when I move the screen. Try to do it without, it gets blurry. There's a certain location at which the image is really sharp. That location is the image distance between the lens and the screen, and I can measure it with a ruler. The distance from the object to the lens is called the object distance. There's my lens. My object is all the way across the messy garage over there, and it's those lights that are strung from the wall. Okay? The next thing I'm going to show you might kind of blow you away. You can see something interesting here. There's some reflection right there. There's something odd in the image there. That is the aluminum foil insulation that I have on my garage door, which is being shined by the light up here. So that is also an object which you can see an image of there. So what we're actually seeing here is an upside down version of what the object is. That's what the image looks like. It's an upside down version of the object. Watch what happens when I open my garage door. Again, we're looking at the screen. What you see is kind of blurry, but it's blurry because this object is further away, so the image is going to actually be sharper when I move the screen closer. Watch this. I'll move it so you can see it better. It's closer, and I'll give you more of the image that you can see. What you see there, it's much sharper when I get it just the right spot at the exact image location. There we go. We see some trees here. You can actually see a car right here. There's my car. But it's an upside down version of what's outside. There's the outside. And there's the image of it. And that's what we're going to be doing in today's lab. We're going to be measuring the object distance and the image distance from a lens, and also the object size as compared to the image size. This image size is a lot smaller, of course, than the actual object, but it can go the other way around too. We'll see that in lab. But hopefully this gives you the idea conceptually of what a converging lens can do.